Good morning, everyone. This is one more session with respect to Linux system programming. In this session, we need to start with another concept that is called threads, or also called as a multi-threading. So, before starting with the today's session, if my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear as well as able to see the screen properly, please type 1 in the chat box. If my voice is clear as well as able to see the screen properly, please type 1 in the chat box. I'm waiting for your reply. Only one message came. I'm waiting for your reply. Okay. Thank you very much. If you're able to recollect, what is the discussion happened in the last session? In the last session, we are trying to understand a little bit more about the concept called semaphores. Again, in the last session, little bit more about the concept called semaphores we are trying to understand. And I need to tell you one point. We implemented a synchronization mechanism between the two processes when they are trying to access a common resource using a semaphore concept. So, semaphore is a mechanism which is used to communicate between the two processes, not for exchanging the data, not for exchanging the data, will you agree, which is used to communicate between the two processes for what purpose? For synchronization purpose. Will you agree? Synchronization purpose. Now, yesterday, one more concept we are trying to understand, that is called a deadlock situation. One process is already locked one resource, waiting for second resource availability, and whereas this is a first resource, this is a second resource, whereas second process locked second resource waiting for first resource availability. So both are waiting for each other to release the respected locks. So then such situation is called as deadlock situation. How to overcome that, we are trying to understand. As a programmer, as a system programmer, when you are writing the program, you should know how many resources your process required. If all the resources are available, then only you need to enter into the critical section of code. If all the resources are available, then only you need to enter into the critical section of code. Otherwise, you should wait for all the resources availability. Otherwise, you need to wait for all the resource availability. So that type of discussion happened in the last session. Today we need to discuss the concept called threads, or we can call as multi-threading. Today we need to discuss the concept called threads, or we can call as a multi-threading. Now, my simple question is, now observe, my simple question is, just give me 1 minute of time. Suppose Just suppose if I write one program, in this program, two while ones are there. In this program, two while ones are there. Can you tell me, when I compile this program, when I run this program, when I compile this program, when I run this program, which while one will execute? Again, in this program, there are two while ones are there. In this while one, I am performing one task. In this while one, I am performing another task. My question is, when I compile this program, when I run this program, which task is going to execute? Again, when I compile this program, when I run this program, which task is going to execute? First while one, can I say this task will execute, this task will never execute? What is the reason? What is the reason behind this? Can you tell me why like this? Only with this while one. Can I say after completion of this only it will come and it will execute this? It means my process. Again, if I compile this program, I'll get an executable file. What is the name of the executable file? If I compile this program, I'll get an executable file. What is the name of the executable file? Name of the executable file is a.out. When I load this a.out into the RAM for execution, can I say this a.out becomes, when I load this a.out into the RAM for execution, this a.out becomes a process. This a.out becomes a process. Now this process can execute only this while one. As a C programmer, this while one will never execute. Let's understand this with another different example. Just give me 1 minute of time. Let's understand this. I'll delete this. Let's suppose I'll design two functions, void task1, void task2, void. Now task1, task2. Okay, so now void task1, void. In this there is a while one loop. In this there is a while one loop. Void task2, void. In this there is a while one loop. Now tell me, how many function definitions you are observing in this program? Tell me how many function definitions you are observing in this program. BE9 S8, it is wrong. In this program, you are observing three function definitions. Three function definitions. One is the main, one is a task1, one is a task2. One is a main, one is a task1, one is a task2. My question is, when I load my program into the RAM for execution, When a process is created, all of you know that underscore start calls the main. Will you agree? Underscore start calls the main. Hmm? Underscore start calls the main. Now you tell me, main is calling the task one here. Will you agree? Main is calling the task one. Hmm? Now tell me, after this task one function execution, my program execution will go back. Again, task two is going to be called. After task one function execution, my program will go back. My program will go back. My program will go back. And my program will go back from task one function to the main. My program will go back from task one to the main, and it will, from the task one to the main, it will call the task two. But my question is, task two will never execute. My question is, the task two function will never gets called. Listen, the task two function never gets called. Why? Because task one function execution is not yet completed. Task two function never called. Now my question is, to achieve this task one and task two to execute concurrently, then what you need to do? To achieve this, task one while one also should execute, task two while one also should execute. So what we need to do? Those two while ones should run in my program. Those two while ones should run in my program. What we need to do? Those two while ones should run in my program. What we need to do? Can I say we need to go for two processes? Can I say we need to go for two processes? Using the fork system call, we need to create a processes, the two processes. Now you tell me, if I write here, if fork double equals to 0, else. Now tell me, in this program, who will do the task one job? Who will do the task two job? In this program, who will do the task one job and who will do the task two job? In this program, who will execute the task one while one? Who will execute the task two while one? Can I say task one while one is executed by the child process? Try to understand the term. Task one while one is executed by the child process. Task two while one is executed by the parent process. Again, task one while one is executed by the task one while one is executed by the task one while one is executed by the child process. Task two while one is executed by the parent process. So can I say to run these two tasks, we created a two processes. To run these two tasks concurrently, we created a two processes, parent and child. Now our requirement is, in one process itself, I want to do multitasking. In one process itself, you want to do multitasking. I don't want two different processes. In a single process only, I want to do multitasking. In a single process only, the two tasks to be done concurrently. Then we need to go for the concept called threads. Again, if you want to achieve the multitasking in a single process, then you need to go for the threads. Now here, multitasking is done by creating the two processes. Please try to respond here. Here, multitasking is done by creating a two processes, but my requirement is in a single process itself, but my requirement is in a single process itself, two tasks concurrently should be executed. My requirement is in a single process, two tasks should be executed concurrently. So in such case, we need to do the, in such case, we need to go for threading concept. Thread is nothing but a lightweight process. So note it down. Unless you're getting the point. In a single process, if you want to achieve the multitasking, in single process, in single process, if we want to achieve in a single process, if you want to achieve multitasking, that also concurrent, in a single process, if you want to achieve the multitasking, that also concurrent, we need to create threads. In a single process, if we want to achieve the multitasking, we need to create a threads. So question is, first is, what is the thread? What is the thread? Answer is, thread is a light weight process. Answer is, thread is a small process in big process. Thread is nothing but a small process in a big process. I don't know. I hope all of you are having a smartphones with you. All of you might have using a different applications in your mobile. All of you might have using a different applications in your mobile. Every application is one process in your mobile. Again, every application is one process in your mobile. If you take an example, one application is cricket update application. One application is cricket update application. Another application is money control application. Another application is Facebook application. Consider there are three examples. Every application in your mobile is a every application in your mobile, when you start executing, please reply it. Every application in your mobile, when you start executing, it becomes a every application in your mobile, when it is started executing, it becomes a process. It becomes a process. Now, how many of you know that if suppose this is a cricket update application, in this cricket update application, it may be divided into multiple windows. Do you know? If you are using the cricket update application, it may be divided into multiple windows. Here you might have observed some advertisements may be scrolling. This is a task 1. Here you might have observed, here you might have observed, so there are two cricket matches are going on. Match 1 information. Now here, match 2 information. Here, some highlights will be there. Like this. Again, there may be one more advertisement scrolling down. Now tell me, this is one process. In this process, 1, 2, 3, 4, 5 lightweight processes are running there. The cricket update is one application. In that, 5 lightweight processes are running there. Will you agree? So these are not a multiple processes here. These are a threads in this process. I need to ask you, when you close this application, will you agree all these threads are terminated? When you close that application, will you agree all the threads are gets terminated? Now, anybody knows this app that is called Money Control? If somebody is like know about the share market and what you call mutual funds and all other things, saving related things or investment related apps. So if you observe this Money Control app or some example XYZ app, so what happens is there also so many small tasks in a single screen you will observe. Yeah, in a phone pay also multiple things will be there. Every application nowadays, whatever the applications you are using in your mobile, in one screen, there are multiple informations, multiple works are going to be happened. Multiple works are going to be happened. Now, can you tell me through phone pay, when you send a message, when you send an amount to your friend, after sending successfully, will you agree? It will ask you, if you want, you can check your account balance. There one small window will come. In that small window, it will show you, do you want to check your balance? Yes or no? Now, can I say, when you click that in a in a what you call phone pay application, one small process is created, one small process is initiated. That process is going to link with your UPI or whatever, your bank or whatever it is. Suppose you are paying your electricity bill through phone pay or Google Pay. So when you click that button to pay, can I say one small process is created in this big process? Will you agree? When you click that button, one small process is created in the big process. That nothing but a lightweight process. That is nothing but a thread. All of you are imagining, all of you are able to understand. A thread is nothing but a small process in a big process. Thread is nothing but a small process in a big process. Will you agree? Nowadays, the smartphone user want everything should be in one single click in one app. Will you agree? Again, nowadays, most of the end user, end customers, they want single app. In that single app, multiple things should be done. Yes or no? When you double click that app, when you start that app, can I say one process is created? Can I say one process is created? In that process, depends upon your requirement, small processes are going to be created. Assume that you went to a shop and you want to pay through online. So then what you will do? You went for one shop, you want to pay through online. There is one barcode scanner is there. So what you will do in your phone pay? You will scan. There is a scan button will be there. You will click that scan button. Now, can you imagine as a developer, as a programmer, can you think what happens? Already PhonePe application is running. That application is one process. Already PhonePe application is running. That application is one process. Now, when you click the button called scan, one small process is created in the PhonePe application. That is small thread is created. A lightweight process is created. All of you are observing this. All of you are observing this. All of you are able to understand this. So, if you think like this, now can you tell me, if I open this, can I open multiple tabs here? Can I say which application I am using here? Which application I am using here? Which application is this? Okay, Edge. So, can I, when I click this here plus button, can I say in this application only one small window is created? That is one small process is created in this big process. All of you are observing. Now, can you tell me what is the use of this application? Chrome, web browsing. This also for web browsing or for document or whatever it is. Now, will you agree? When you open this application, in this application you can you can open multiple windows. In multiple windows, multiple works you can do it, but application is only one. But application is only one. Or if you're getting the point, can I say here also the concept called thread? Thread is nothing but a small process in a big process. Here also the concept called thread. Thread is nothing but a small process in a big process. Now tell me, when I close this application, no matter how many windows you opened, every window will close. When you close that application, no matter how many sub windows you created, everyone will close, everything will close. Now, when you close your PhonePe application, can I say how many internally, how many small processes, threads are running? All those threads will terminate. All of you are getting this point. So, what is the meaning of a thread? Thread is nothing but a small process in a big process. Thread is nothing but a small process in a big process. Thread is nothing but a lightweight process. Every process is a single thread process. Till now, every process is a single thread, only one thread. Main is a thread, main thread. Again, if you think about thread terminology point of view, if you think about thread terminology point of view, main is a thread, a lightweight process. All of you are getting the point? If you think about thread terms point of view, main is treated as a main thread. Main is treated as a main thread. One process contains, till now, one process contains a single thread. But now, in one process, we are going to create multiple threads. Means multiple while ones is going to execute, but when I type ps, only one a dot out will be there. When I type ps, only one a dot out will be there. All of you are getting the point? So when I write dot slash a dot out, till now only one thread is created, that is a main thread. But now we are going to create a sub threads. But now we are going to create multiple threads. Now try to understand here. This is a thread 1, this is a thread 2, This is a thread 3. All the 3 threads are sharing the 8 MB of a stack. Don't think that for this 8 MB, for this 8 MB, for this 8 MB. No. All the multiple threads will share the same resources. Registers, code section, data section, files. We'll discuss that. So many points we need to observe here. I hope you got a little bit information about a thread. So if somebody asks what is a thread means, thread is nothing but a lightweight process. Thread is nothing but a small process in a big process. Using the threads, what we can achieve? If somebody asks using the thread what we can achieve, in one process we can achieve multitasking. Note it down. What is the use of the thread means? What is the use of the thread means? In one process we can achieve the multitasking. In one process we can achieve the multitasking. In one process we can achieve the multitasking. Now you may get a doubt, sir, to achieve the multitasking, I can create multiple processes. Then what is the need of multiple threads? Again, suppose task 1 is there, task 2 is there. Suppose there are 2 tasks, one is a task 1, one is a task 2. To run these 2 tasks, I can create 2 different processes. To run these 2 tasks, I can create 2 different processes. But you may get a doubt, sir, what is the need of creating a thread here? Again, to run 2 different tasks, you can creating a 2 different. To run the 2 different tasks, you can create a 2 different processes. Will you agree? To run the 2 different tasks, you can go for creating a 2 different processes. But instead of creating a 2 different processes, in a single process only, you can achieve the multitasking using the threads. Now, what is the advantage of threads compared to the process? We need to discuss it. What is the advantage of threads compared to process? We need to discuss it. Suppose now here there is a process 1, there is a process 2. What is the process 1 is doing? What is the process 1 is doing? Task 1. What is the process 2 is going to do? What is the process 2 is going to do? Task 2. In the right hand side, in a single process, there is a thread 1, there is a thread 2. What is the thread 1 is doing? Same task 1. What is the thread 2 is doing? Same task 2. User point of view, there is no difference. User point of view, this is also running, this is also running. Here also this is also running, this is also running. Now tell me, execution point of view, if you think it, now tell me, these 2 threads are present in a, these 2 threads are present in a, those 2 threads are present in a one process. Those 2 threads are present in a one process. Now tell me, here 2 PCBs are created. Here 2 PCBs are created for every process. Separate PCB, separate time slice, separate signal table, separate file table. Everything is separate. Separate data section, separate code section, separate heap section. Everything is separate. But now you tell me, here these 2 tasks, these 2 threads are present in a single process. Can I say these two threads will share the things? Now here there is no two PCBs are created here. In this case, in a thread case, two PCBs are not created. Only single PCB. But for every thread, one separate block in the PCB, that is called a TCB. Can anybody tell me the full form of TCB? Again, for every thread in a process, in a single process, for every thread, there is one data structure is created. There is one data structure is created that is called TCB. TCB is nothing but thread control block. So now tell me, these two works are done under a single process or under two different processes? Those two works are done under the single process or under two different processes? Can I say under a single process, BE9S8, one process, multiple threads. External world identifies this as a external world identifies this as a external world identifies this as a single process, but inside multiple works are concurrently going on. Inside multiple works are concurrently going on. Now here two processes, two tasks, but my requirement is these two tasks is a part of a single process in that single task. So instead of creating the multiple processes, better go for, if these two tasks is a small tasks in a big task, instead of creating a two different processes, better go for two threads. Yes, advantage is concurrency within a process. Correct. Not only that, there are so many advantages are there. BE9S8 advantage is single process concurrent execution. That is the first advantage. Second advantage is tell me, if two processes wants to communicate between each other, they need to take the help of IPC mechanism. If two processes wants to communicate between each other, they need to take the help of IPC mechanism. But if two threads in a single process wants to communicate between each other, they no need to take any IPC mechanism. Just they need to put a data into the global variable. Again, if two threads wants to communicate between each other, if two threads wants to communicate between each other, if two threads wants to communicate between each other which are present in a single process, they no need to take any IPC mechanism, just a matter of putting the data into the global array. Because for these two threads which are present in a single process, same data section will be there, common data section will be there, common code section will be there. All of you are observing this diagram, previous diagram. The two threads which are present in a single process, observe common code section, common code section, common data section, common files. Now tell me, if you declare a static variable, the memory is allocated. Can you tell me, if you declare a static variable, the memory is allocated? The memory is allocated. If you declare a static variable, the memory is allocated in a data section. Now, can I say this thread can put the data into this data section? This thread can read the data from the data section because this is the common, because those are common. So now can you tell me, when two threads wants to communicate between each other, do they need any IPC mechanisms like pipe, named pipe, message queue, shared memory? Again, if two threads wants to communicate between each other, do they need any IPC mechanisms like pipe, named pipe, message queue, shared memory like this? Answer is no. Can I say it is just a matter of putting the data into the global array? Can I say it is just a matter of putting the data into a global array? But if in between two thread, if in between two processes, if you want to communicate, suppose in between two processes you want to communicate, then you need to take the help of kernel supported mechanisms. You need to take the help of kernel supported methods, kernel supported process, kernel supported procedures. What are those? IPC mechanisms. What is that? IPC mechanisms. Listen, now can I write one statement here? First advantage is, first advantage is, what is it? First advantage, in single process, we can achieve multitasking. Second, if multiple threads BE9M8, yes, absolutely correct. In WhatsApp, chats, status, voice call, video call, whatever it is, that is a whatever it is, that is a small processes in that big process. Is it clear? Small processes in that big process. So now tell me, if multiple threads in a single process wants to communicate, they no need to take the help of any IPC. If multiple threads in a single process, they wants to communicate, they no need to take the help of, they no need to take the help of any IPC. It is just putting the data into global array. It is just a matter of putting the data into global array. Is it clear? So this is one of the advantage. Second advantage is thread context switch is faster compared to the thread context switch is faster than process context switch. Again, second advantage is thread context switch is faster compared to the thread context switch is faster compared to the process context switch. Can you tell me what is the meaning of context switch? What happens when the context switch is happening? Try to understand, try to recollect the concept. What is the meaning of context switch? What happens when the context switch is happening? What is the purpose of context switching? What is the purpose of context switching? Can I say the purpose of context switching is to achieve concurrent execution. Okay, the purpose of context switching is to achieve the concurrent execution. Before completion of one process, if another process wants to execute, the context switch should be done. Before completion of one process, if another process wants to get the CPU time to execute, will you agree the context switch is required? Before completion of one process, if another process wants to get the CPU time to get executed, when I say context switch is required, please respond it yes or no. Now observe, when two processes context switch is going on, total PCB should be loaded and unloaded. Loaded and unloaded. From where to where? From 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 PCB to CPU registers. From CPU registers to the PCB. Who will maintain the PCBs? Can you tell me who will maintain the PCBs? Where the PCBs are present? At this stage, I'm expecting the answer from you. Yes, process manager will maintain the PCBs. Where? Where? In a hard disk or in a RAM? Process manager will maintain the PCBs. Where? In a hard disk or in a RAM? Answer is in a RAM. In user space or in a kernel space? In user space or in a kernel space? Answer is in a kernel space. Now will you agree? When this process wants to execute, process manager need to load this PCB into the CPU registers. Entire PCB member should be loaded into the CPU registers. Suppose if PCB contains 50 members, now when the context switch is going on between these two processes, all the 50 members should be loaded and unloaded from RAM to the CPU registers, from CPU registers to the RAM. Suppose my PCB contains the 50 members. Suppose if my PCB contains the 50 members, so all the 50 members must and should be loaded into the loaded and unloaded. Now can you tell me if can you tell me in a single process if multiple threads are there, in a single process if multiple threads are there, entire PCB is no need to be going to be loaded and unloaded. Only TCB is going to be loaded and unloaded. Again, in a single process, if in single process, if multiple threads are present, so when the thread contact switch is going on, when the thread contact switch is going to happen, so entire PCB of that particular process no need to be loaded and unloaded. Only that respected PCB is going to be loaded and unloaded. Can I say in this way the time gets saved? In this way, suppose entire PCB contains 50 members. In this 25 members are common members and remaining 25 members are different. So when the contact switch is going on between these two threads, these 25 common members no need to be loaded and unloaded. Only the remaining 25 which are not common, that should be loaded and unloaded. Remaining 25 which are not common, that should be loaded and unloaded. Remaining 25 which is not common, that should be loaded and unloaded. So in this way, can we say the thread contact switch is faster compared to the thread contact switch is faster compared to the process context switch. Why? Because when the context switch between the two processes are happening, when the context switch between the two processes are happening, entire PCB entire PCB member should be loaded and unloaded. But when the context between the two threads which are present in the single process, so then not the entire PCB members no need to be loaded and unloaded. Only few members which are not common between the threads, those to be loaded and unloaded. So thread contact switch is faster compared to the process context switch. If you understood this point, type 2 in the chat box. If you understood this point, type 2 in the chat box. So one advantage is in a single process, we can achieve multitasking. Second is if multiple threads are in a single process, if they want to communicate between each other, they no need to take any they no need to take the help of any IPC mechanism. It is just a matter of putting the data into the global array. Next advantage is thread context switch is faster than the process context switch. So these are the major points. All these points are present in this material. All these points are present in this material. Whenever you have the time, you can go through that. First, observe this. It is difficult to share information between the processes. Why? Because we need to take the help of IPC mechanism. Sharing the information between the threads is easy and faster. It is just a matter of copying the data into the global array. So we can avoid the what? We no need to take the help of any IPC manager here. Is it clear? Again, you may get a doubt, sir. There are two threads are present in a single process. If this thread is putting the data into the global variable, this thread is getting the data from the global variable, or both are putting the data. Can I say there is a data gets mixed here? Again, here also the same problem is there. If two threads are putting the data into the global array at a time, the data gets merged, the data gets mixed, the data unexpected data will be there. Now, what we need to do here? Can you tell me in this case what we need to do? Can you tell me in this case what we need to do? Can I say we need to use some thread synchronization technique? Now tell me, if two processes are accessing the common resource, then from the last two sessions we are trying to understand semaphore process synchronization. Getting the point? If two processes wants to communicate between these two processes wants to synchronize, you need to take the help of semaphore. But now try to understand these two are processes or threads. Tell me, these two are processes or threads. These two are processes or threads. Can I say those are threads? These two threads are present in a these two threads are present in a single process. Those two threads are present in a single process. Now that try to understand if these two threads wants to synchronize, we need to take the help of mutex. Thread synchronization can be achieved using a concept called mutex. I'll write it here. Fourth point, thread synchronization can be done using mutex. Again, thread synchronization can be done using the concept called a mutex. So we need to discuss that also, maybe in a tomorrow session, whatever it is. Is it clear? So I hope now theoretically it is clear. So thread is nothing but a lightweight process. Thread is nothing but a small process in a big process. So advantage of the thread is, if multiple threads wants to communicate which are present in a single process, no need to take any IPC mechanism. And if contact switch between the threads is faster compared to the processes. And only one disadvantage is, here also there is a one disadvantage is, here also we need to take the help of some synchronization if they are trying to access the common resource. So now the question is, sir, how to create a thread? What is the method to create a thread? Now observe, these are the common things. Beside global memory, threads also share number of attributes: PID, PPID, control terminal, user ID, group ID, open file descriptors, record logs, signal dispositions, timers, all these things, resource limits, niceness value, all these things are what? All these things are what? Common members in the PCB. So they no need to load and unload at the time of context switching. These are the common members. They no need to load and unload when the context switch is going on between the two processes. These are the common things. They no need to load and unload when the context switch between two threads in a single process is going on. But these are not common threads. Distinct. Distinct means these are not common things. Thread ID, signal mask, thread specific data, error numbers, floating point environments, scheduling policies, stack. For every thread, separate stack. The 8 MB of a stack is divided into multiple threads. That 8 MB of a stack, whenever your process is created, that 8 MB of a stack is divided into multiple threads. What are these? From point number 1 to point number 8, what are these? Is these are common or not common points? These are the common points or not common points? Can I say these are the not common? Now can I say, when thread context switch is going on, only these members should be loaded and unloaded? Will you agree? When the thread context switch is going on, only this not common parameters is going to be loaded and unloaded. Now the question arises, so sir, theoretically, okay, then how to create a thread? So to create a thread, we need to take the help of some functions. To create a thread, we need to take the help of some functions. Observe. Now here, how many functions are there? 1, 2, 3, 4. Just a minute. 5, 6, 7, 8, 9, 10. Last 3 functions are used. Last few functions are used for what? For mutex purpose, mutual exclusion, synchronization purpose. We will discuss what is the difference between the semaphore and mutex and all other things, because interview point of view that is very important. So before that, let's understand how to create a thread. What is the next discussion? What is the next discussion? Next discussion is how to create a thread. What is the function involved to create a thread? What is the function involved to create a thread? Pthread underscore create. All of you copy the prototype of this. All of you copy the prototype of this function. Pthread underscore create function. All of you copy this and copy this information also. Very important information. Just 1 minute, I'll come back. Just 1 minute, I'll come back. All of you copied this. Pthread underscore create. All of you copied this function prototype. Pthread underscore create. Okay. So what is the return type of this function? What is the return type of this function? Integer. And in this, one very important argument you need to understand this one. Which one? This is the first argument or second argument or third argument? In this, which argument? Can I say that is the third argument? Will you agree? The third argument. This is a function pointer. Third argument. It is a function pointer. Means which function you want to register as a thread, that function you need to pass. Which function you want to make it as a thread, that function you need to pass there. Which function you want to register as a thread, that function address you need to pass there. And one more important point, whenever you are compiling the thread related program, you need to use this -pthread, linked with -pthread. I don't know you remembered or not, when we are discussing a dynamic runtime linking, DL open, DL sim, DL error, we need to compile and link with -LDL. If you are using math related functions, you need to use -LM. I don't know you remembered or not. So when I'm talking about library concept, I told you by default linker links with 3 libraries. First one and last one is the operating system related library. Second one is the our C library. Again, the first one and last one is the OS related library. Second one is the C library. In that library, these function definitions will not be available. In that library, these function definitions will not be available. So you need to compile with -pthread. This is one of the important. If you see this, you may get little bit worried, but don't worry. I'll show you the program. It is very easy. When you saw the prototype, you might have worried about what you need to pass and all other things. So vi t1.c hash include, just a minute, hash include header.h void thread underscore one void. I hope all of you know that if you're defining above the main, no need to declare. If you're defining any function above the main, no need to declare thread underscore one. Okay, that is in a while one. Void main. Now observe pthread underscore t1. Now tell me, t1 is a variable of which type? Can you tell me? T1 is a variable of which type? T1 is a variable of which type? Can I say pthread underscore t type? T1 is a variable of which type? Can I say pthread underscore t type? Now observe pthread underscore create. First argument is ampersand of t1. Second argument is 0. Third argument is thread underscore 1. Fourth argument is 0. And here while 1 printf in main PID is equals to %d slash n get PID. In thread 1 PID is equals to %d slash n comma get PID. Now can you tell me, in this program, how many function definitions you are observing? How many while ones you are observing? In this program, how many function definitions you are observing? How many while ones you are observing? In this program, how many function definitions you are observing? How many while ones you are observing? Can I say two function definitions? One is a main, one is a thread underscore one. There are two function definitions. One is a main, one is a thread underscore one. And also two while ones. One while one is a main function. Another while one is a thread one function. There are two while ones. One while one is in a main function. Another while one is in a thread one function. Will you agree? Now let me compile this code. How to compile? Is it normally? How to compile? You need to compile like this, cct1.c. No. What you need to do? Hyphen pthread. Hyphen pthread. I think in a header.h, pthread.h is there, right? So how many arguments here? Just pthread underscore create address of t1 0. How many arguments? Okay, let's see how to avoid that warning, why that warning is coming. Passing pthread from incompatible pointer type thread 1. Oh, what is the thread 1, man? Pthread underscore create argument. Return type is a void pointer, argument is also void pointer, right? So sorry, I created a wrong function. Return type is also void pointer, return type is a void pointer, argument is also void pointer. Now let's see this. What is this? Void star. Void star variable name you need to supply. Now observe. Now observe the. Now tell me. In main while one is also running. In thread one while one is also running. All of you able to feel? In main while one is also running. In thread one while one is also running. But process IDs both are same or not? Now here two processes are single process. Observe. Here two processes are a single process. Can you tell me? Here two processes are a single process. Will you agree here a single process? But in a single process, but in a single process, how many threads? Two threads. What are those? In a single process, there are two threads. What are those? Can I say main and thread one? Main is also treated as main thread, as I told you. Main is also called as a main thread. Main and thread one. Now in a processes, we need to use parent process and child process. Suppose in one process, if another process is created using the fork, can I say this is the parent process and this is a child process? Now here, parent and child relation will not be there. Main thread is created a subthread. Again, in this thread management, there is no parent and child relation, main thread and subthread. All of you are getting the point? Now here, which thread is created which thread? Now tell me, in this program, which thread is created which thread? In this program, which thread is created which thread? Main thread is created thread 1. Main is creating the thread 1. BE9C2. Is it clear? Main is creating the thread 1. Main is creating the thread 1. So what is the relation between the main and thread 1 here? What is the relation between the main and thread 1? Here not a parent and child relation. Here it is not a parent and child relation. Now here, with respect to thread terminology, we need to make it as sub-thread. We need to pronounce, we need to say main thread is creating the sub-thread, not the child thread. All of you are getting the point? Type 1 in the chat box. In this thread management, because everything is common, everything is shared. So here we should not say child thread, we need to say sub thread. So these two threads, process ID is same. In these two threads, process ID is same, but thread ID will be different. TID is equals to percentile U pthread underscore self. What is the get PID function will give us? what is the get PID function will give us? PID is equals to percentile U. Again, my question is, what is the get PID function will give us? Process ID. Can you guess what is the pthread underscore self function will give us? Can you guess what is the pthread underscore self function will give us? Can you guess what is the pthread underscore self function will give us? Thread ID. Every thread is having a separate ID. Every thread is having a separate ID. Now let me compile the code. Let me show you here. Let me compile the code here. Again, one important point while compiling. What you need to? Hyphen pthread. While compiling, you need to use hyphen pthread. Now tell me, thread IDs are same or different? Thread IDs are same or different? Thread IDs are same or different? Can you tell me what is the main thread ID? Last 2 digits at least. Can you tell me what is the main thread ID? Last 2 digits 68. What is the thread 1 thread ID? What is the thread 1 thread ID? 24. But both process IDs same. Now tell me, from another terminal when I observe ps-e this ps-e, now observe 2423, only one process is there. 2423, one process is there, but in that process multitasking we are achieving. In that multitasking, I hope with this example you are able to understand what happening in background. In one process, small processes are created. Main is a main thread and subthread. Is it clear? So in a tomorrow session, tomorrow more same as it is 7:30 morning. In a tomorrow session, we discuss what is this. This already you know. What is this argument? We need to discuss. Some more functions we need to discuss about the threads. Thread synchronization using the mutex, we need to discuss it. Is it clear? In a tomorrow session, we need to talk about some more thread related things and what is the return type. All these things we need to discuss it. And so many other functions we need to discuss it. Tomorrow class will be morning 7:30. It's clear to everyone? So maximum this Sunday I'm going to wind up this. Monday onwards new schedules will be there. I'll announce it in a last session of the process this Linux system program. Thank you very much. I'll share this program in the LMS. Thank you very much. I'll share this program in the LMS.